these data follow a lovely pattern, right? A parabola. Yes? But the correlation coefficient is 0. Right? They follow a nice pattern, but that pattern is not linear at all. If I did my best job of fitting a line to these data, it would be a horizontal line. Yes? So because the slope of that line would be 0, the correlation coefficient is 0. If the slope of the line would have been positive, correlation coefficient would have been positive. Negative, negative. So, OK. All right. So this is to drive home the idea that the correlation coefficient measures association, but it only measures linear association, not nonlinear association. So here is a slightly less clean example. Here we've got we got nonlinear association, right? This thing is all sinuous, S-shaped, whatever. The scatter in a vertical strip is relatively small compared to the overall scatter in the plot, so the association is pretty strong. The correlation coefficient is 0.7. It's not small, but why is it not small? It's not because of this clustering. It's not because of this. It's because if you fit a line to it, right, the line does a pretty good job of predicting the value. It's systematically above in some places, systematically below, but somehow a lot of the variation in the vertical variable can be, quote unquote, explained by a straight line. Straight line takes up most of the difference. Okay, is this all right?
So I mean, the line that we draw through it, does it take into account like just y values? Because from what I see, it kind of just measures like the distance from like the line, like y.
Okay, so what R is basically measuring, I mean, another way to think about it is if you put a line through this and you compare the overall scatter in the plot to how much scatter there is around the line. You sort of subtracted the line from each point. Then if that ratio is big, if after you subtract the line, there's not much scatter left compared to what you started with, then the correlation coefficient will be big. Okay. If that line slopes up, it'll be big and positive. If that line slopes down, R will be big and negative. Yes? It's not the slope of the line. If the line has positive slope, the correlation coefficient will be positive. If the line has negative slope, the correlation coefficient will be negative. But R will be 1 if all the points lie on a line that has even a microscopically positive slope. So the magnitude of R is sort of measuring how near the points are to the line compared to how near they are to each other overall, vertically. Yes?
So for like, let's say there's a sine wave,
yep.
the R would be 1, right? Because it's going like through a straight line.
If you really had a full cycle of a sine wave, then the best fitting line is going to be horizontal. And you're going to, well, actually, no, if you did that, the best fitting line would probably tilt this way because you have a bunch of positive values here and a bunch of negative values there. So you have a line that slopes down a little bit. You would get a negative correlation coefficient, but it wouldn't be -1 because they don't lie on the line. They're scattered around the line.